of all, wanted to thank everyone for joining us this morning. My name is Tom Robbins, and I am with PlayFab, and I appreciate we've got what looks to be a really good turnout for one of the many series of educational webinars that we have focused on PlayFab as well as learning about live games. You can always sign up, and we always encourage people to sign up for our webinars, which are available at playfab.com/webinars. We always do our best to make any video available, barring any technical difficulties, after the webinar, and you can also find that on playfab.com/videos or on our YouTube channel. So for those of you who have joined us today, I appreciate it. And today is really a webinar that was driven based on what a lot of people had asked us for. We did a webinar a couple of weeks ago on CloudScript, and we had a lot of really great questions, and we had users who had actually asked us to do an advanced CloudScript webinar, which I'm happy to say is what we're going to do today. So without much further ado, I'm going to hand it off to Brendan, our Senior Developer Success Engineer, who's going to go over some advanced CloudScript. And for those of you that are listening, if you have questions, feel free to place them in the chat box, which is usually on the right-hand side of your screen or your questions box, and we will do our best to answer them. So Brendan, over to you.
Thanks, Tom. Hi, everybody. So this is Brendan once again. And as Tom just said, we're going to talk through some more advanced CloudScript. Basically, this is the continuation of our previous talk, getting started with CloudScript. So the first thing I'm going to do is I'm going to walk you all through a quick recap of what we discussed in that talk, just in case there's anyone on the line who didn't get a chance to see that one yet. I'll review how to actually run a CloudScript, since that's really the key component to understand before we get into the details of today's talk. Then I'll talk to the scenarios that we're going to be talking about today, which those of you who saw the last talk, you're going to be very familiar with, because I'm basically pulling in those scenarios from last time and talking through them. And then I'll update with a few resources at the end. Okay. So in the last talk, what we did was we walked through all of the fundamentals of CloudScript. What is it? It is JavaScript, which is arbitrary code written by you, hosted by us in PlayFab, that you can run for your title, allowing you to have server-side authoritative calls for your title so that players, can't cheat the things that you don't want them to cheat, basically, or where it needs to be server-side for other security reasons. We talked about how to create scripts, how you do revision control in our service, using them with webhooks, which is the Photon cloud system for making calls to actions based upon players entering or leaving rooms, or arbitrary action triggers that you can make as a call to the Photon cloud. We talked a little bit about debugging, and then we talked through the usage scenarios, and finally the limitations. And I've got an update on that. We had some really good discussions internally on limitations. We will be publishing those shortly to this site. But the first thing I need to point out is that last time I said that the total execution time for a CloudScript needed to be 1 second or less. We've changed our minds on that. We're actually going longer. We're making it 3 seconds or less, which is in, of course, server CPU time, a tremendous amount of time. So it should be enough for most scenarios. Again, though, if you have really complex behaviors that you want to be able to simulate in the cloud, you may want to consider using a custom game server. Okay, so let's get right to it. In order to call a CloudScript, there we go. First, you need to make sure that you ask the service for the URL that you need to use for calling a CloudScript. You only really need to do this once when your game starts. I would not suggest storing it locally for subsequent launches of the game. It is possible for the specific server endpoint to change. But realistically, over the course of one player's session, I would not expect it to change. So you make the call before you do any Cloud Script calls, and then for each Cloud Script call, that's the URL that you would use. When you actually launch the Cloud Script calls, you make the call passing in whatever parameters you need. There's a couple of ways you can do that. There's params and params encoded. I tend to use the encoded version, particularly for illustrative purposes, because it's a little easier to follow. And then once the call is complete, you get back a response. One thing I didn't really highlight last time is that when the Cloud Script runs, unless something goes wrong from a technical standpoint of running the script, the response code from our service is always going to be the code 200 OK. So don't expect that that code there is a status code you're returning. Any returned values that you set up as part of your script are going to come back in the data below, specifically in the results section. You also have the opportunity to do logging for any kind of debugging that you want to do, and that comes out in the action log near the bottom. And then again, the total execution time, keeping it under 3 seconds, is always shown at the bottom. So when you're doing your testing, you'll have the opportunity to review that. And if you see a script that's running really long, it's running 2.5 or higher seconds, you'll really want to have a look at it and try and decide how you might want to optimize it. Okay. So the main thing in terms of resources for CloudScript is our GitHub. We post some samples here, and we will continue to post additional samples over time that give you some of the fundamentals that you need in order to run. And we'll be posting some more advanced ones there as opportunity presents. I also want to strongly encourage everyone out there that if you have some examples of CloudScript functionality that you think is really cool, send it our way. We'll post it here. Or even you could just submit it directly in GitHub. So the ones that we have there right now, we've got the asynchronous matchmaker. That's the companion script that goes along with our blog post on that topic. There's the basic sample, which is the Cloud Script, which is automatically revision 1 for any new title created in the service. So if you create a title right now, that basic sample will already be revision 1 in your Cloud Script. And I'll show you a couple pieces of that in just a minute. There's also the Photon Cloud integration. That's actually, if you go into it, that's actually a link over to a larger GitHub project, which is both sides of the Photon Cloud sample. So it's a full sample for working with Photon through PlayFab, both for authentication and using webhooks. And then finally, there's a fairly simple one, the rewards sample, which shows how to grant items to players based upon their actions. And we'll actually go into that one in this as well. So the very first thing in the basic sample in our GitHub is hello world, because yeah, there's always got to be hello world. This is obviously not advanced. I'll just very briefly just show you, okay, everything that you call in CloudScript is a handler. You pass in arguments that you can use. We don't use any in here because it's just a hello world. In this case, we're creating a message, throwing it into the log, and returning it. Okay, really, really simple. So let's move on to something a little more interesting. I told you I was going to cover the scenarios from last time. That's exactly what I'm going to do. So where you see up top the basics, I didn't point this out on the previous slide that was from the old deck, but basics indicates this is one of the slides from the previous talk. Okay, so this was our scenario 1, how to update the player to the current revision, depending upon any changes that you might need to make. If you've removed an item from your game entirely, like let's say you're a card game, a collectible card game, and you found that one card really imbalances the game, and you want to get rid of it, swap it for something else, this is what you would want to do, is you would basically have an onLogin type of function, which you could use for more than just updating. You call into it, and you update the player for any of those changes you need to make. Now you'll notice I highlighted this one section called the previous version handler. Okay, I hadn't written out my full examples when we did the last talk, so my bad, folks. Don't do this as an iterative call from 7 to 6 to 5 to 4 to 3 to 2 to 1. As I pointed out last time, you are limited to 10 API calls into PlayFab from within your CloudScript execution. So calling iteratively into previous revision functions would probably push you over that limit, so probably not your best idea. Instead, you'll want to roll all your changes into one update call. So walking into this a little bit, when you call the player login, which is what I've decided to call my handler, I've defined the current version for the game. It's going to be 7. There's a key which I've stored in user internal data called user version. I query for that using the server call getUserInternalData. Once I've got it, then I can just compare it to the current version that I've defined. Okay, now you could convert that to a numeric value, but I mean, honestly, it doesn't really matter. You're just comparing an equals. You could have your versions be names if you prefer. There's certainly some fairly large companies that do that very thing and choose some very silly names. Okay, so once you've determined that you're not on the current version, you would want to update the player to the latest version. So you call into your update version 7, again, rolling up any changes that get you from 1 to 7. Once that's done, then you'll update user internal data for the player to get them onto the current version. So the next time you run and you do this check, it doesn't go into the update. Okay. Moving on to the next scenario, player actions. So again, this is from the last talk. This is the one where we talked about making sure that when a player takes an action, you have the opportunity to validate that action against your expectations of whether or not it's realistic. Could the player have made the move? Does he have the right items to do what he's saying he did? Basically, it's cheat prevention. And in my case, swapping slides, there we go. In my case, I chose to show you a check against time. So in this particular case, what we're saying is a player has made a move, but in my game, a player could realistically only make a move every 15 seconds. If it's coming in faster than that, that means he's hacked his client or he's doing something else that's not legitimate, like posting messages into my service using a tool instead of actually running the game. I don't want to allow that. So what I'm doing is I'm grabbing the date from the server using date now. I get the user internal data. Again, I'm storing it in internal data so that the client can't even see it. Only the server can update this. Grabbing the last move timestamp for this player. Once I've got it, then I go ahead and parse it. So I'm parsing it out as a date because, of course, everything is string. All of these key value pairs are always strings. So once I've parsed it out, I can compare it to the last, I can compare them now to the last move time. Since time is always returned in milliseconds, I'm dividing by 1,000 to get it to seconds. And if the last move time tells me that, yeah, he's making it too fast, then great. I can say, no, this is not legitimate. The player did not have enough time pass. He's not allowed to make this move yet. And so if the player has, so he passes the check, it's been at least 15 seconds, then I know everything's okay. I can go ahead and get the statistics. I increment the moves, or if he didn't have any moves, I set it to 1. I update the statistics, and then I set the internal data for the latest timestamp to make sure that we have the latest version there for the next time this runs. Okay, rewards. So again, this going back, this is the one which I said is in the CloudScript samples in our GitHub. The idea of rewards is that a player has taken some action, like the moves in the last example, for instance. The evaluation here, that's what I just showed you. So now I'm just going to show you actually granting the item to the player based upon the action taken. So in this particular case, in the GitHub sample, we've defined the rewards as just as an array in the header of the actual script itself. One thing you could do if you wanted to is you could define these rewards in title internal data if you wanted to have it stored separately. That means that instead of updating the cloud script whenever you wanted to change out your rewards, you'd be able to just adjust it in title internal data without having to post a new revision to the cloud scripts. You'll notice that some of these rewards have 1, some of the rewards have 2. Doesn't really matter. The call we're going to make gives you the ability to grant as many items as you need to the player. Okay, so we call into the onLevelComplete, and you can see here we do some basic input validation. In this case, we're checking the level number. Is it legitimate? Is it actually a level that's in your game? Assuming that it is, okay, we go ahead and we take the key, which is the level completion, level completed with the level num tagged onto it, and we grab that out of internal data. So the question we're asking now is, did the player already complete this level? A few years back at GDC, one of the guys from CCP did a fantastic talk on analytics in their system, and one of the things he highlighted as part of it was they had this tremendous spike in usage on gameplay on one particular mission in EVE Online. And the reason for that is because there was actually a bug in their game that allowed players to go back and replay a mission that they should only ever have been able to do once. So this is the kind of check that you want to have in your logic to make sure that that does not happen. Okay, assuming we've passed all of those tests and any other tests that you want to add in, maybe time-based, maybe total amount of damage done, whatever, we pick the rewards from the array that we set up at the beginning, and we go ahead and we reward that to the player using grant items to user. In this case, we're setting the annotation to given by completing level, just so that you have a record of that when you're reviewing the player's inventory later in the game manager. And then finally, we're returning the items that were given to the player as the results from the cloud script. If you remember from near the beginning of the talk, it all comes back in data for the return from calling the cloud script. Okay, and then the last thing we do after that is we update level tracking. Like I just said, the player, we're checking to see whether or not the player has played the level before so that he can't, use the loophole in question that I talked about with Eve and play the level over and over and get the reward again and again. So you set it to true, he's already played this level, great. You block that off and you return the results. Okay. From the last talk again, scenario form messaging. Okay, this is being able to send messages between players. Push messages are great. This is really, what I'm talking about now is about being able to send an arbitrary message from one player to another using shared group data. And you pass that in using the ID of the PlayFab ID of the player. Now, one thing I will highlight, the reason I'm saying use a shared group data for this, because technically you could post that into the read-only user data of a player, or frankly, you could post it into the regular user data since you're not really concerned about somebody modifying it. That is true, you could do that. However, as I said, we're going to post those limits soon, and one of the limits that we're going to be talking about in the overall write-up is that we're going to limit the total keys within each bucket to 100 is our thinking right now. And in particular, I need to point out one thing about the limits, something I didn't highlight earlier. All of the limits that we're defining in our service, by and large, are adjustable. So if you have a requirement in your game for something that goes beyond the bounds of one of our limits, then just reach out to us and let us know. We can talk through what would need to happen in order for us to be able to push beyond one of the limits that we're setting. But for now, we're saying, call it 100 keys for each bucket. So user data, read-only user data, internal user data, each of those at the title level would have 100, and then each at the publisher level would also have 100. Okay, so because you have a limited number, just create it as a shared group data. The shared group data then also has 100 keys that you can write into. Obviously, we'll be limiting the total number of shared group datas that you can create, but we'll be doing it as a factor of how many players you have in the game. So don't worry, if you have 1 million players, you will have the ability to create millions of shared group datas. Okay. So you create a specific bucket for the shared group data, and you're going to write into it using the PlayFab ID of the player sending the message as the key, and then his message as the value. Okay. So you would really expect this to work then. You call a function where you say you've got a message group ID. This is your shared group ID. You call to update the shared group ID with the current player ID as the key and the message as the value. Okay, yeah, you might, but that doesn't work. You see here, what's actually happening in that case is the key is literally current player ID. It's not the actual PlayFab ID of the player. This is definitely kind of a WAT moment. And if you guys haven't watched the Destroy All Software talk on WAT, I highly recommend it because it is, if you're as nerdy as me, hysterically funny. Okay, so yeah, that actually doesn't work. What you really need to do is this. There we go, slide change. Is you actually have to set up a data payload which contains the key in it and write the key value pair there so that you can write it out as the data payload to the call into it. That actually allows you to write the key being some variable that you're setting in your game logic. Just something I wanted to highlight because it has tripped up a few people that I've talked to. So there you go. Leaving a message from one player to another is as simple as that. You basically just pass in the message that you want to pass to the player. You create your data payload with the key of the player ID and the payload of the message as the value, and you drop it into the update shared group data call, and you've left the message for another player. Okay. Again, you're only going to have 100 keys to work with, although, again, work with us if you need more. We can work things for you. But since that total space is limited, you want to remove messages once you've actually used them, once players actually read them, seen them, used them in the game, depending upon what the payload is. It might actually be some logic command that the game takes an action on. So on the cloud script that you have for consuming the message, it's a check messages call. You basically grab the shared group ID, current player ID messages, which is what we set up previously for the message group ID. You grab all of the data in it by calling get shared group data without specifying any keys, and then you iterate through all the messages and take whatever action you need to on each one of them. As you're doing that, set the value for each of them to null. That way, when you then call update shared group data at the end, the data payload contains null for the value for each of the keys, which then deletes them all from the shared group data, freeing up the key space. All right. Now, the last scenario that I talked about last time was being able to have extra columns for your leaderboard. All right, my bad, guys. I have to say, this is not one that's really valid. I actually sat down and worked out the details of this, and yeah, the issue here is that the shared group ID is actually the index for the table in DynamoDB. So I can talk through the details with anybody who needs to get into the nitty-gritty of it. But long story short, you cannot have an unlimited number of keys in a shared group ID. And that's one of the reasons why we are specifying a limit in the limits that we'll be posting to the site. Okay, so to make up for you for this one, I've added another scenario, web API calls. So this is all about calling out from our service using the HTTP function in CloudScript to make a secure call to your own website, your own server, or a third-party server that you've got set up with some functionality that you need, or any other arbitrary third-party server that has functionality you'd like to use for your game. So the question you got to ask yourself when setting this up is, what are your needs in terms of security? There's two primary ways to do this. There's an almost unlimited number of ways you could do this, but there's two primary ones that I'll talk about. The first is to use the session ticket as your security for talking to your server. So the session ticket is what you get back from PlayFab on any login call for the user. So when a user authenticates with PlayFab, the session ticket is returned. It is unique to that player and that session, and it's valid currently for 24 hours, though that could change in future, so don't rely upon it necessarily being 24 hours. The idea of the session ticket then is that any call you make to PlayFab requires the session ticket as the authentication, and anytime you make a call into PlayFab from your game, you always check the return value to see whether or not the error coming back, if you get an error back, whether or not the error coming back is that the ticket has expired. And if it has, you just sign the user back in again. And there's also a blog all about best practices in terms of sign-in. We can point you to that. Feel free to let us know if you'd like a specific pointer at the end of the call, and we'll make sure that it's part of the resources we make available. Okay. So when you call out, if you want to use the session ticket as your auth mechanism into your service call, then you would pass in the session ticket as an argument into the handler that you call. So in my case, I've defined an external call handler. It's calling out to your domain, and just for the sake of this example, we're saying it's in a PlayFab, and there's an action that you're taking. And it's a post call because we've got to get some data up to you. That's the data values that we're passing in. We go ahead and stringify the object body so that we can pass it in through the HTTP request. Content type is going to be application JSON. And then the headers, the authorization, that's where you pass in the session ticket that you passed in as your arguments to this particular handler. And then you just make the HTTP request call using the URL method, body type, and headers that we've defined. Now, that's using session ticket. Most secure third-party services they're not going to take that, of course. On the server side, if you're using the session ticket, what you'd do is you'd use the server API call authenticate session ticket to validate that with our service. So that's a server-to-server call that your server would make to ours to say, is the session ticket that I've been handed valid? And our service passes back the information on whether or not it is. But again, most third parties, that's not going to be good enough. So for them, I would recommend asking them if they use OAuth. Or you may want to set it up with your own service if you really want it to be more secure than just using the session ticket. And again, these are all SSL-based calls, so you don't need to worry about man-in-the-middle attacks on them, generally speaking. Okay. In this particular case, an OAuth 2 call is a web API call, so it's not a problem for use with our service. We can make any web API call that you need to out from CloudScript. The normal process for OAuth 2 is that you use a local secret key to request a token from the OAuth 2 service. And then you would use that token, which is usually referred to as the bearer token, to access secure calls from that service. Now, I do recommend in this case that you make that particular bearer token have a very short lifetime. Bear in mind that your CloudScript call itself can only be a maximum of 3 seconds, so there's really no point in having a long bearer token lifetime. Okay, so the first step you need to do here is you use your secret key to get your client, to get a client-specific token from the OAuth service. So you can store your secret key in PlayFab. You can store it in user internal data, title internal data. It all comes down to the specifics of your OAuth implementation and what kind of uniqueness you need for your secret key. If you store it in internal data in PlayFab, then there's no way for the client to even see it. So that's a way to add an extra layer of security to your system overall. So you would send a call into your domain. Usually the call to get your bearer token is something like request token, so that's what I'm calling it here. In the body, we're requesting a bearer token type. In this case, you're going to want the content type to be form URL encoded. That's just, generally speaking, if you're talking to somebody who's using an OAuth type implementation, these are the headers you're going to see. If you have any trouble at all, though, with this, if you encounter a provider who has something a little bit different, let us know, and we'll certainly work with you and them to make sure that everything works out right. The secret key, then, is passed in as a basic token. Most OAuth 2 implementations, that's the nomenclature that they use for this. Again, your mileage may vary. We'll work with you if you run into somebody doing something different. But you'd make this call in. The data coming back, you parse it as JSON, and within that, you're looking for the access token. The access token is your bearer token. So once you've got that, in this case, we're returning it. This is a function, by the way. I probably should have stated at the beginning. This is a function that you've defined within your CloudScript to get the access token using the secret key. So you're not passing that back to the client. What you're doing in this case is you've got a handler in your CloudScript which calls to get the access token. which is returning that to the handler itself, which is what we show in the next slide. Okay. Once you have the bearer token, so you see here, we go into the external call function, we get the access token, the bearer access token, excuse me, from the function that we defined earlier. You can see it's about 3/4 of the way down in this call. We define the URL, it's a post message, we're defining the data that we want to send up, stringify it, it's application JSON, and there's the bearer access token retrieval. So you use that function you defined to get your bearer access token, and you define that as your authorization header. And then again, you're just passing it into HTTP request with the values you've defined. And really, I don't want to make it sound like this is trivial, but it's as simple as that. That is effectively a complete OAuth2 call made from CloudScript. We actually have a couple of titles who are using that specifically to do OAuth2 right now, and that's essentially everything that they do in order to make their calls, apart from some game-specific logic. And there you go. That's all 5 scenarios that we talked about last time, replacing, obviously, scenario 5 with one that I think is a little bit more useful to you guys and gives you a little bit more functionality. We've got some resources here. Obviously, we've got the tutorial on our site, which walks you through how to use CloudScript, sort of a getting started guide for CloudScript. There's the link to the GitHub, and our blog post, which talked about the implementation that Dave and Buster's did in using CloudScript for their service, just to give you an idea of some of the possibilities of things that you can do using CloudScript. So those are some mainline scenarios, I would say. Those are some of the most common things that I think titles are going to need to use. If you guys have suggestions for other, maybe more arcane or specific activities that you'd like to have your game take, more actions you'd like to see occur in CloudScript, feel free to send them our way. I'd be happy to set up another talk to talk through additional advanced CloudScript scenario topics, show you some more ways to do interesting things. Really, it's all up to you, whatever you need. So with that, I just want to turn it over to you guys for questions. I see that, yep, we're only a little over past the half-hour mark, so we made good time on this. Feel free to post your questions into the webinar, and we can walk through those and make sure to answer any outstanding issues that you might have.
Thanks, Brendan. Please, as Brendan said, go ahead and send in your questions, and we'll do our best to answer. We've still got a little bit of time. I've got one question that says, can you call into your custom server from your cloud script?
Okay. So the concept here is that you'd have a custom game server running in the cloud, specifically in PlayFab, and that you'd then be able to call into it from a CloudScript call. So it's sort of like you're hosting 2 different ways in our service. One would be the logic in CloudScript, and one would be custom game servers. My first response would be, you don't really need to, honestly, because you've already got a custom game server running. It's actually not as limited as CloudScript. It's able to make more calls into our service. It's running for a lot longer period of time. But that said, realistically, you would need to proxy that call somehow, because you're going to have a DNS-capable endpoint that you can write to, which you can that you can post the HTTP call to. Since all of the custom game servers run in either AWS EC2 or in SoftLayer, they actually have non-deterministic IP addresses. So it's not really predictable, and they're not really a DNS-defined endpoint.
Another question is, what would you recommend not running in CloudScript?
Wow, what would I recommend not? The most common one that you're going to need, or I should say the most common scenario for games that really you're going to need a custom game server for, is hosting of action game sessions. So think of Call of Duty and games like it. Those are games where really you need to have a lot of processing power, you need to have long executions running a lot of logic. If you've got sophisticated AIs that need to make a lot of complex decisions, that's probably going to take more than 3 seconds of total compute time. Basically, it's things where really a lot of real-time activity has to occur based upon player actions, or where you've got really large amounts of complex calculations that have to be made. Those are situations where you really are going to have a custom game server. There are games that are doing AI in CloudScript right now, so don't be scared off by doing any form of AI. I would just say, keep an eye on what it is that you're doing, how you're doing it, and what your total execution time is. I mean, if you're making some, fairly straightforward, maybe doing quick calculations using an A-star algorithm, or just even simple state machine decisions based upon, current situation of player or whatever, and determining what action needs to be taken by the game based upon the state. Those are great ways you could set up AIs in the game. It's just, if you're talking about doing something, much higher level, you're doing, I don't know, fuzzy logic calculations on things, doing a whole chess simulation, something like that. That's something that's not going to happen in 3 seconds.
Great. We've got a couple more questions. People, please feel free to continue sending them in. So the next question is, my cloud script is really long. Is there a way to use classes or something else to bring up all the functions into multiple scripts, or to organize and update better?
Aha, okay. So one thing I did not talk about is what's in the future for CloudScript. So and actually this is probably a great topic for a future talk. When we actually release these updates, I'm going to see about scheduling a talk where we can walk through the new functionality and how to get the most out of it. What we have on our plate that we're going to be working on in the very near future is an update to CloudScript, which is going to give you two things, more than two, but the two primary components of it are this. One is having the ability to have multiple files in your CloudScript so that you can divide up all of your logic into classes, however you need, divvy it up amongst all the different individual files so that you don't have one massive file. I know that right now that can be a little bit, I don't know how to use the word intimidating. It can just be a little bit annoying, let's say, to have everything in one script. So we are going to solve for that. Just as important, though, the other thing that the update will provide you is a much better debugging solution. So right now, as we talked about in the last talk, the debugging for CloudScript is effectively the log functionality that we provide to you. So you get back, any errors, messages that occur because of, bad, like a bug, an actual bug in the CloudScript causing an error from our side. But you also have the ability to use all the logging information to tell yourself what all has happened at each stage throughout the calls. The new system will actually provide you with real-time debugging so that you'll be able to have a much easier time working with your CloudScript and developing them.
Great. And I've got a couple of questions around webhooks. So is it possible to adjust Photon webhook URLs in PlayFab, or are they handled only in CloudScript or somewhere else?
So possible to adjust Photon webhook URLs. It's funny. We've actually got a representative from Photon in this talk right now, but I can't really. Yeah, he just said hi on the chat. He's actually very active in our forums as well, so I just want to take a sec to just as a side note. Hamza, thank you so much for all you do helping to support the Photon folks in the PlayFab community. Really appreciate it. So yeah, the Photon webhooks in PlayFab, really what it is that in the Photon cloud, they have the webhook set up to call into specific handlers in our service. So they're not really URLs per se. Honestly, at the moment, I'm trying to decide what the scenario is you have in mind. If you want to expand on that a little bit, feel free to add a little bit more to the question. But I think the short answer is going to be no. That when you join a room, for instance, it calls out to a specific webhook handler, which you can have in CloudScript. So it's just in the case of joining a room, it's room joined.
So I think we have a little bit more information. It says, are webhooks handled once for every action or once for every client who handles the action? For example, if a player joins the Photon room with 5 players, will handlers.roomJoin be called once or 5 times?
If player joins the Photon room, I think, okay, to clarify the question, I think what you're saying is if 5 different players join a Photon room, is the webhook called 5 times? And the answer is yes. The webhook handler, in the case of joining a room, is going to be called for each player that joins it. Now, one clarification. There's 2 different ways a player can join the room. One is by starting the room, and one is by joining the room. When you start the room, it calls the room start handler, not the room joined. But for every player who joins an existing room, the webhook handler for room joined is going to be called in the context of that individual player. So you'll be able to take your action in your webhook based upon the specific PlayFab ID of the player in question.
All right. So could CloudScript respond to PlayFab events, perhaps when a user is registered or similar?
So, okay. We do have events in our system. We are discussing making events be hooks for your own custom logic. So how's this? I can't promise that that's going to happen soon, but you better believe we are definitely looking at that right now. That is a great concept. Thank you.
All right. And then actually one question from Hamza. 100 keys could not be enough for a shared group that could contain a master list for ongoing games. How would you do that?
Yeah, that's a very good point. If you have a very large number of players and you wanted to do tracking on a bunch of games, so let's say you've got an asynchronous game like a card game where you play it, or let's use Words with Friends. Everybody's familiar with that one. So I make a move and then my friend makes a move and on and on and on and on and on. So yes, you would not be able to use a single shared group to track on every single one of the games taking place. Realistically, I would say it depends upon what your goal is. You're never going to need to throw the list of every game being played at every player. That's not really a scenario that's viable when you talk about having a user base of hundreds of thousands or millions of players. So you're probably going to want to divide that up in some way. The simplest thing is you'll have separate shared group data for tracking of games that are being played between players. So I'll have the list of all the games that I'm in. And yeah, that means that I'm limited to having 100 games running at any given time. If you've got players who need more than 100 games running at one time, that is a great problem to have. But yes, needless to say, yeah, you'd track on it that way. Some other things you could do if you're looking to have highlighted games, for instance. Let's say you're doing tracking on your best players, say using our leaderboard system. Maybe one thing that you want to do is over time determine who the players are who are the most interesting, the players that, if you've got a Twitch stream or something, the ones that people want to see playing. Maybe then you use your title data to define a set of player IDs, a set of PlayFab IDs, excuse me, where you want to track on those guys in particular to be able to highlight them to your community. So every time one of those guys plays a game, you would write out not just their own shared group data for tracking their own local games, but a global one that everyone can access of those games. Does that make sense?
Another one. So what about Photon room state then? Maybe a shared group per room?
Oh, that's an interesting point. Yes, that's actually a really good idea. Using the Photon room state, updating the Photon room state as a shared group per room. Yes, sorry, I'm just sort of thinking through that one off the top of my head. I can certainly see that working. What you would have then is you would have shared group data on a per room basis. Rooms are generally speaking, they're tied very closely to the number of players you have, so that's certainly a very viable way to track on data for the Photon Cloud room state. Yeah.
Perfect. Well, we still have time. If anyone has any additional questions, please feel free to send them in. As I had said earlier, we hope that you enjoy these webinars. We really are trying to make it easy to get involved and to start learning PlayFab as well as live games. You can always find webinars on playfab.com/webinars. You can always look at the videos that we have, everything from how-tos to overviews of various aspects of live games and old webinars at playfab.com/videos. So it looks like we don't have any additional questions. So I'm going to go ahead and end our webinar for today. We absolutely appreciate everyone joining us. And Brendan, thank you for spending the time today. And everyone have a great day.
Thanks, Adam.